Now, we'll take up one more problem on the simply supported beam, the problem number 12. It reads as, draw the SFD and BMD of the simply supported beam loaded as shown in the figure. So here you have a simply supported beam, and we have two vertical loads which is acting upwards, which is at A and B, which is RAV and RBV. And then we have a point load at the point C of 4 kilonewton, which is at a distance of 2 meters from the end A. And the UDL is between D and E of 2 kilonewton meter for a span of 4 meters. But the point D starts from 3 meters from the left support. Then we have at the point F, wherein you have 8 kilonewton, which is at a distance of 679 meters from the point A. So this is how the loads are acting on the beam. Now we will going to find out the support reactions first. So we have the sum of the vertical forces is acting on the beam, and also the sum of the moments also acting on the beam, but the problem is on the horizontal load. So now we want, as there is no horizontal load, so it will going to be 0. So now we are going to take up the, because there are two unknowns, one is RA and the other one is RB. Now we want to fix at the point A. So that means when you fix at the point A, RA will not exist. So we need to find out the RBV, which is at a distance of 10 meters from A. Now how to do that? Taking the moments about the point A, sum of the clockwise couple will be equal to anti-clockwise couple, which will be equal to RBV into 12, RBV into 10 equals the sum of the moments on the clockwise direction will be equal to the sum of the moments on the counterclockwise direction. So that will be equal to 8 into 9 plus 2 into 4 by 2 plus 3 plus 4 into 2. So that means you have 8 into 9 plus 2 into 4 by 2 plus 3, then plus 4 into 2. So on simplification, you will going to get that RBV will be equal to 12 kilonewton. So now also what we know, the sum of the vertical reaction acting upwards will be equal to the sum of the vertical reaction acting downwards at the respective points from the beam C, D, E and F respectively. Now also RAV plus RBV, as the load is acting upwards, is positive, so it will be equal to the load acting downwards, which will going to be point load of 4, then the point load of UDL of 2 kilonewton per meter for a distance of 4 meters. So 2 kilonewton per meter means, since it is 4 meters, so 2 into 4, then plus 8 will be equal to 0. So on simplification, you will going to get it as RAV will be equal to RBV is 12, and then you have 4 into 2 is 8 plus 8 16 plus 4 is 20, so 20 minus 12. So on simplification, you will going to get it as 8 kilonewton from at the fixed support at the point A. Therefore, RAV will be equal to 8 kilonewton. Now we are going to try to analyze this problem now. So first we are going to consider between A and C, starting from the left towards the right. So when you are considering from the left towards the right, so at the point A, we have RAV, which is the vertical reaction, which will be equal to 8 kilonewton. Then, which is at the point C, we are not considering the load first, but we are considering only without load, we are considering the point C. So between A and C, as there is no other load acting on the beam, therefore it remains constant. So SF remains constant between A and C. So between A and C, it is constant at plus 8 kilonewton. So that is what we have shown here. SF at the point A is plus 8 kilonewton, and between A and C, it is constant at plus 8 kilonewton. Now, what will going to be the bending moment at the point A? So the bending moment at the point A will be equal to 0, and bending moment at the point C, which will going to be, since it sags the bending moment, so naturally it becomes positive. So 8 into 2 plus 8 into 2 will be equal to 16 kilonewton meter. So this is how you will be able to get this point from 0 to 16 kilonewton meter, which is on the point C of the beam. Now we will going to consider the next condition wherein we are applying the point load C, the point load of 4 kilonewton at the point C, and we take the distance of 1 meters and then from C to D, which is going to be 1 meter. Now what will going to be the SF at the point C? SF at the point C will be equal to plus 8 minus 4. Plus 8 minus 4, we will be getting that as plus 4 kilonewton. So between at the point C, it will going to be plus 4 kilonewton. So between C and D, as there is no other load which is acting on the beam, therefore it remains constant at plus 4 kilonewton. So this has been as shown in this figure, wherein at the point C you have 8 kilonewton. So and then when the point is considered, or the point load of 4 kilonewton is considered at the point C, then it drops down to 4 kilonewton. And between C and D, as there is no other load is acting on the beam, therefore it remains constant at plus 4 kilonewton. Now what will going to be the bending moment at the point D? So BM at D will be equal to 8 into 3 minus 4 into 1, which will be equal to plus 20 kilonewton meter. So again from here, it goes to the upward direction to plus 20 kilonewton meter. So that is how you will going to get at 16 kilonewton meter first, and then from there it rises to 20 kilonewton meter, which is at the point G. Now we will going to consider the UDL, which is from D to E. So to do that, so from D to E, you have to consider the UDL. What is the SF at the point D now? SF at the point D will be equal to plus 4 kilonewton. Then SF at the point E will be equal to plus 4 plus 2 into plus 4 minus 2 into 4, which will be equal to minus 4 kilonewton. So when you are considering this, at the point D you have 4 kilonewton. At the point E you are getting minus 4 kilonewton. Then join between 4 kilonewton to 4 kilonewton at the downward direction, which will going to be negative here. Then so since it will going to vary linearly, that is because you have a UDL, which is W into X. So since it is W into X, so the power of X is 1. So naturally we are going to get a linear curve. So it is minus 4 kilonewton. Then what will going to be the BM at the point E now? So BM at the point E will be equal to plus 8 into 7 minus 4 into 5 minus 2 into 4 into 4 by 2. So on simplification, you will going to get it as 20 kilonewton meter. So from here, it takes up to 20 kilonewton meter. So now we will going to consider only the point. We cannot draw the parabolic curve. That is basically because we are not able to get the maximum bending moment. That is because since the sign is changing in the shear force, so the bending moment will be going to be maximum at that particular point. So next we are going to consider between F and B now. How to consider between F and B. So now when you are considering that between E and F, what happens? It will going to, so there is no load which is acting on the beam. So it will going to remain constant of minus 4 kilonewton. So SF varies linearly from plus 4 kilonewton to minus 4 kilonewton, and between D and E it is constant at 4 kilonewton between E and F now. Now BM at F will be equal to 8 into 9 minus 4 into 7 minus 2 into 4 into 4 by 2 plus 2. So this will going to be plus 12 kilonewton meter. So when you are plotting this, so from here to here, you will going to get plus 20 to further drops down to 12 kilonewton meter at the point F. Then we have the total load coming on the beam now at the point B. So SF at F will be equal to minus 4 minus 8, which will be equal to minus 12 kilonewton. Between F and B, as there is no load acting on the beam, it remains constant at minus 12 kilonewton. So SF at the point B will be equal to minus 12 kilonewton. So you can see here SF at F, because due to the point load, it will drops down to 12 kilonewton. So minus 12 kilonewton. And between F and B, it remains constant at minus 12 kilonewton. So SF at B will be equal to minus 12 kilonewton. So this is how you will be able to analyze the shear force diagram. Now, what will going to be the bending moment at the point B now? So the bending moment at the point B will be equal to plus 8 into 10, then minus 4 into 4 into 8, minus 4 into 8, minus 4 into 2 into 4 by 2, minus 4, 2 into 4 into 4 by 2, plus 3. So that will be equal to bending moment at the point B, which will be 2 by 2 plus 3 from with respect to this. Then minus 8 into 1, it will be equal to 0. So maximum bending moment occurs where the SF changes its sign. So let G be the point at a distance of x from A where SF changes its sign. So now we need to consider SF at the point G will be equal to 0 now. So when you're considering the SF at the point G, which is at this point where the SF changes its sign, which will be equal to 0. So then what happens? 8 minus 4 into 2 into x minus 3. So that is because at the distance of x minus, so that the section takes between the UDL. So the UDL will going to be acting at the distance of x meters from D now. So that is minus 2 into x. That is the total distance. X is from here to here, it is total x. X minus 3 will going to give you. So this distance, which will be between the section xx, that is G to D, is x minus 3. So minus 2 into x minus 3. So on simplification, you will going to get it as x is equal to 5 meters. So from here to here, from the intersection or from this section point where the SF changes its sign to the free end of the point A will going to be 5 meters. So this is how you will be able to get this point. Now we need to find out what will going to be the bending moment diagram at the point G now. So at the point G, you will going to have 8, so that distance is 5 meters. So 8 into 5 minus 4 into this 5 minus 2, which becomes 3, minus 2 into 5 minus 3 is 2, 2 into 2 into 2 by 2. So that will be equal to plus 24 kilonewton meter. So once you get this point, so when you point at the point G, you will going to get 24 kilonewton meter. Then join from 20 kilonewton meter passing through 24 kilonewton meter and then comes to plus 20 kilonewton meter because you have a UDL. Since it is a UDL, it is W into x by 2. So Wx square by 2. So the power of x is 2. Therefore, the joining between the 2 points will going to have a parabolic curve. So since at the point G, shear force is changes in sign, so according to the convention, at that particular point, you will going to get the maximum bending moment, so which will going to be plus 24 kilonewton meter. So this is how you will be able to get the final solution. Thank you.